The fastest speed achieved by a man-made object was 73,800 meters per second by the Juno spacecraft. That is approximately 0.02% the speed of light. We are slow, and we desperately want to exceed that speed. Take a look at Newton's kinetic energy equation. We have all seen and used it multiple times, and with a little pondering you would realize that with making v squared the subject, increasing energy and decreasing mass leads to an increase in velocity. Intuitively, we can assume that for a large enough energy and a small enough mass, the speed of light can be exceeded, can't it? This is where these two men come into play, Bertozzi and Einstein. Einstein theorized in his theory of relativity that Newton's equations break down at high speeds, close to about 10% the speed of light. These speeds are called relativistic speeds. He believed that the speed of light had to stay the fastest known speed no matter what, and he thus proposed an equation for the kinetic energy of a relativistic object, centered on this belief. Notice that if the object's velocity equals to the speed of light, the denominator equals to 0 and the equation becomes undefined. Dr. William Bertozzi was an MIT professor who proved that Einstein's equations were right. How did he do it? Well, he first noted, as we did earlier, that for a fixed mass, the more we increase energy, the higher its velocity. Secondly, he noticed that for a fixed amount of energy, the lower the object's mass, the higher its velocity. Thus, to reach the relativistic speeds, Bertozzi decided to use electrons, which have a mass of about 9.1 times 10 to the minus 31 kg. He charged the electrons with a Van de Graaff generator and gave the electrons a known amount of charge, measured in MeV. He then shot these electrons through the particle accelerator of length 8.4 meters. He then measured the time it took the electrons to travel that distance from the beginning of the tube to the end, where it crashed into an aluminum plate. He then used this equation, speed equals distance over time, to calculate the speed. He did this for 0.5, 1, 1.5, 4.5, and 15 MeV. The corresponding speeds were 2.6, 2.8, 2.9, 3, and 3. It is clearly seen that the speeds approached a limit. Even when we jump from 4.5 to 15 MeV, the speeds stay the same. The limit is the speed of light, proving that no matter how much energy you provide an object with, they cannot physically surpass this speed, disproving Newton and solidifying Einstein's ideas. What if the electrons did not receive all the energy it was given by the generator, and the energy was somehow lost? Well, he repeated the experiment and attached a piece of apparatus that measures the thermal energy released by the electrons upon collision with the aluminum plate. When the thermal energy was calculated, it was almost the same as the kinetic energy given to the electrons at the beginning of the experiment. The experiment yielded results close to those that were produced by Einstein's equations for objects at relativistic speeds. However, at lower non-relativistic speeds, Newton's equations overlap with Einstein's and thus can be used to yield correct results. There is a limit to everything in our universe. An object will change its mass and even its length as it gets faster, just to make sure that light reigns supreme.